Hi. Right now, we want to talk about the payback period. It's occasionally used and probably the simplest method for assessing a project's viability. It's determined by looking at the cash flow of a project and considering both its costs and its benefits, or its costs, inflows and outflows of the cash flow, up until the point at which the benefits equal the cost outlays. The time at which this event comes to pass is referred to as the payback period. A few comments then, perhaps, on the payback period. A shorter payback period is better than a longer payback period. Obviously, your inflows are compensating you for your outflows sooner, and so that would be considered a good thing. Now, with that, the shorter the payback period, the less the implied risk. So it's a kind of an implied risk assessment. If you have a short payback period, it's going to pay off sooner. You're not in jeopardy anymore. And so it's kind of built into the process, although I wouldn't rely too strongly on it. So some disadvantages then. The first one is the time value of money. The payback period, by definition, does not include discounted cash flows. And so while for short duration projects that might not matter too much, if you go longer and longer and longer, the discounting rate is going to make a bigger impact. And so that would makes this disadvantageous as far as having a clear picture of what the financial situation of your project really is. And so we see it here, less meaningful for longer periods of time due to that absence. It's more difficult to use when the cash flow changes over time. I wouldn't put too much stock into this. I mean, quite frankly, spreadsheet technology and everything else, it really isn't that difficult. It certainly is more difficult to calculate a whole bunch of independent cash flow transactions than, say, an annuity, which can be approximated fairly quickly. But again, I wouldn't put a whole lot of stock in that. Perhaps the red flag is that it ignores transactions after the payback period. Because all you're interested in is determining when you've come to a positive cash flow, any continued positive cash flow or negative cash flow for that matter would be blind to this process. You've already come back with your payback period, and the actual sort of net benefit or net risk is going to be lost because we're truncating our analysis at the time of payback. So, having said what we said about the time value of money, it is worth noting that you can always use discounted cash flows, and you can do it in a payback period. Now, they theoretically call this the discounted payback period as a technique or a method. I don't differentiate one from the other. I think it's just an option. If your project goes long enough that it's going to matter, discount your cash flows. If it is going fairly short and it's not going to matter and it's an added complexity of no substance, then don't bother. But to me, in my opinion, if you're going to talk about payback period, identify whether you're discounting it or not, but consider the processes themselves as interchangeable, one and the same, if you will. So let's have a look at a quick, simple example, and then we'll look at a slightly more convoluted one right after. So let's start. We're going to have an investment of $1,000 up front. And our expectation is that it will return $200 a year for 10 years that follow. And the question then becomes, what is the payback period? So this is a fairly straightforward calculation. We just take our outlay, $1,000, and we divide it by $200 a year that we're going to make off of that outlay. And we're able to figure out that the payback period is 5 years. Obviously, this is not discounted or anything else. That's the straight up payback period. Now, if we do want to look at a discounted assessment of this same problem, so we need to know what our discount rate is. And of course, this is the first time we've talked about discount rates. They're known in different industries by different terminology. There might be some nuanced difference with one between the other. You're going to use a discount rate, a hurdle rate, a minimum acceptable rate of returns. There's a number of ways we can refer to it. And I will flop in and out of different terminology just to not benefit one industry more than the other. So in this case, using minimum acceptable rate of returns, which is to say 8%, we want to see to compensate for the 2% inflation plus an additional 6% profit on our investment. And it says, what is the discounted payback period in this discounted cash flow? So in this case, there's of course a number of ways we could do this. What I chose to do in this case is we've set this up as our $1,000 has to, or currently is equal to, without discounting, our $200 annuity multiplied by the uniform series discount factor, P given A, and an interest rate of 0 because it's not discounted, and 5 years for the payback period. And because of that, what we can say is what we need to do is we want to take that factor, the uniform series factor, and set it equal to 5, and now look and find out how many years it would take for that factor to be equal to 5 at a discount rate or margin, minimum acceptable rate of return of 8% or 0.08. And so if we go to the tables or go to our spreadsheet, run it through our calculator, however you want to do that, we substitute in for successive values of n. I've shown 5, 6, and 7 here. We get our factor, and we see it's equal to 3.9927 at 5 years, 4.6229 at 6 years, and 5.2064 at 7 years. And so we can see that the discounted payback period would be, something slightly less than 7 years, or to the closest whole number would be 7 years. And so that would be the discounted payback period. So that's one way to do it, easy to do in this case. In the next example, what we're going to do is we're going to do a more complicated cash flow of changing payments in different years. So basically what I'm showing here is over the time from year 0 through to year 6, we have future value payments, if you will, or future payments shown for each year. So of course we have our cash outlay in now and in year 1 of $1,000 and minus $500. And then we're starting to get our benefits or our compensation in positive cash flows starting in year 2 of $500, $700 in year 3, $1,000 in year 4, $1,500 in year 5, $500 in year 6. And you could go on forever. And so this method, if you will, is infinitely flexible and perhaps the easiest to understand exactly what you're doing. So in the problem, they say, what is the payback period without discounting? And then what is the payback period with discounting at a hurdle rate of 15%? So we're going to do a couple things. The first thing I need to do is I just want to have cumulative payments. So in my spreadsheet, I'm just going to do sort of accumulating sum in the next column. And so here we have a column of the cumulative payments. So negative if it's outlay, positive if it's cash inflows. And so we start off, we're down $1,000, we're down $1,500 by the end of year 1, and then we start to recoup that. We're up to minus $1,000 in year 2, minus $300 in year 3, and then we're positive starting in year 4 and continue to go positive in year 5 and year 6. And so we can see from this that our payback without interest or not discounted is 4 years, because we shift into positive cash flow at year 4. And so that's represented here. So now if we wanted to continue this problem just by adding a couple of columns to our spreadsheet to get our discounted payback period, we can do that. And so we take our payments and we multiply them by this formula, 1 plus the interest rate, all to the power of negative t, where t is the time period that you're in. And so by applying that to our f at t, or our future payment, we're able to discount each of them for its specific place on the timeline. And so, again, we see what those periods are, but you see as you get farther and farther away, their future value becomes a lot less compared to what its present value becomes a lot less compared to what its future value is. And so that $500 payment in year 6 is actually only worth about $216 to us right now at this discount rate. So now if we do the same thing as we did before, we basically do a cumulative sum of the discounted payments coming through, and we see that it takes us a little bit longer to get back into a positive cash flow circumstance. And we can get our discounted payback period at the interest rate of 15%, somewhere around 5 years. And that's shown here. And so that's the payback period. You can do it not discounted. That's kind of the original method. And of course, if it's a longer timeline, absolutely discount it for the time value of money. I assume that you understand the fundamental concepts of time value of money, so I'm not going back over that. Just showing its simple application here. And we can see it takes us a little bit longer, typically, to get to that discounted payback period as compared to the payback period. So that's one method to assess a project. It's probably the simplest. It has some value to it, but it certainly has some pitfalls and some concerns that you want to be aware of if you're going to be quoting these as justification in your business case.